Good morning, everyone, and thank you for attending today's webcast, Using Autodesk CFD to Optimize Flow Distribution. Our presenter today is Mark Dooley. He's a Solutions Engineer with Hagerman & Company. Before we get started, I'll let you know that you're in listening only mode. If you have questions during the presentation, you can type them into the question panel on the right-hand side of your screen, and Mark will address them at the end of the presentation. As we close down the session today, you'll be prompted to fill out a survey, and we ask that you take a few moments to fill that out. Additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. With that, I'll hand things over to Mark.
Thank you, Ashley. Thank you, everyone, for joining us. Today's webinar to look at CFD and flow distribution. As Ashley mentioned there, if you do have questions, you can enter those in the GoToMeeting or GoToWebinar chat area, and we'll take a look at those at the end as we wrap up. So our agenda today is take a quick look at the simulation portfolio of products, some simple benefits of CFD, where CFD can help, some of the features, and then a live demonstration of the product. So the simulation portfolio that Autodesk offers is a complete set of simulation products for predicting product performance through optimization and validating designs. On the mechanical side, we've got the Nastran NCAD and the simulation mechanical. The architectural side, the robot structural analysis professional. For fluid flow and thermal analysis, we've got CFD and flow design. For plastic injection molding, the Autodesk mold flow products. And for composite materials, the Helios lineup of products. So some of the benefits of CFD that we'll be taking a look at today is on the fluid and the flow process and pressure testing. But some of the other benefits of CFD are optimization, checking different levels of components, eliminating the ones that are not needed, running through simple analysis of single designs or multiple designs variations. By going through optimization, you're able to predict the lifespan of each component, replace them with better choices up front versus later on in the warranty side of changing out components. Interactive design comparison, the direct integration and the tight integration into the CAD products, Inventor, Pro-E, SolidWorks, CATIA, even working with step files, ASYS, SAT files, and so forth, being able to bring those different files directly in and updating a design without having to start over, and then in the end result, increasing product functionality. So where CFD can help? Well, it can help in multiple genres, multiple industries. On the electronics cooling side, overheating of graphics cards. Our television's getting too hot. The edge lit LEDs, are they too hot on the edges? Are we getting enough air flowing through there? Monitors, appliances, dishwashers, stoves, refrigerators. We're getting enough flow coming through there for everything that's working on the inside to make sure that we're not overheating and burning something on the inside of the housings. The data centers, server rooms, server farms, newsroom studios. We have proper flow coming through for the cameras and things like that. On the lighting side, the light housing, solar panels, switches even. On the machinery and valves, which is kind of where we're going to be looking today, is the fluid and flow side. But then on the AEC side, they also have hospitals, operating rooms, waiting rooms, atriums, entrances to buildings, curtain walls on the exterior of buildings, etc. Are we getting proper flow through here? And so that's where the CFD products come in. What we're looking at today is the flow optimization. But CFD can also be used for erosion visualization, thermal testing, cavitation identification, and so forth. So some of the features right off the top, what sets CFD above everything else, is the CAD-driven design study environment. And that's a live link back to the CAD file. Can easily update your designs inside the CAD window and update that right into CFD without starting over again, without reapplying materials or conditions. Just updating the model, the analysis, running it again, and everything is prepared and you're ready to start studying your results. The mesh auto sizing, command inside CFD automatically creating the mesh. When you select the command there, you don't have to do single faces or single bodies or single components. It just automatically meshes the entire model, saving you a lot of time. Those results can even be transferred to simulation mechanical if you're going on into a more thermal stress analysis. And another advantage is the cloud computing, freeing up your machine so that you're not tying up your machine running the results of the analysis. You can utilize a server farm or cloud computing if you have access to it. And then the CAD system neutral again, CATIA, Autodesk products, SolidWorks, Pro-E, Unigraphics, the different models that we can bring in and show and run analysis on. So now we're going to kick over to and start in Inventor here and take a look at the model, and then we will launch it into CFD and create an analysis here. But on this Inventor model, I have an iAssembly set up here, and in this iAssembly, let me zoom in here, we've got 6 variations of the insert here at the center of the valve. And so choke valve 1, I've got the larger holes, openings right here that in this study we're going to test water coming through. So the water that would come through the inlet and go through the valve and coming out on this side. So we've got 6 different inserts here. And so variation 1 is the larger openings. Variation 2 is we've got these more square openings here, or rectangular openings. Variation 3, we've got smaller circles but more of them. Variation 4, we've got the rectangular slots on the diagonal. And then variation 5, we've got larger slots. We've got 4 wrapped around the component here. And then variation 6, we've got slightly larger rectangular slots but on offsetting angles, one versus the other. And each one of them goes all the way around the model. And I am using Inventor 2017, and I do have this component here set as transparent so that we can kind of see through it without turning it off visibility, so kind of give us that better feel for it there. So any one of these we can have saved, and we do have a simulation tab up here on the ribbon menu, and we can just launch the model directly into CFD from inside of Inventor. And do I want to save? Yes. And it's going to ask me for a name, so I can accept the defaults, or I can give it a specific name, a specific location. I'm just going to select the defaults there and let it launch the model into CFD for me, and it's going to bring it in. And the last known iteration, which in my case was the variation 01, and so it will launch this model for us here fairly quickly. Now, one thing to note is the simplified workflow. Working with AutoCAD, working with Inventor, Autodesk has set those up with that left to right workflow on the ribbon menu. And the same thing comes true here in CFD. We've got to set up the model for analysis before we can view the results. We've got to have the results before we can go to the Decision Center and compare results. So as we are launching our software, we've already created the design here, so we don't have to add or bring anything in. We do have templates that we could set up and rules that we can map materials to and so forth. So when we're bringing a model in from Inventor, we want aluminum to automatically map to the aluminum library, or steel to go to the steel 303, 404, aluminum 6061, whatever it is. We can have those rules set up and in place to where they automatically map. In this case here, I'm not using those. The aluminum did come forward, but the other materials did not. Let me flip back to Inventor real quick here. Inside Inventor, we did model up these caps on the inlet and the outlet here. And we did that to create a watertight feel. So by having those 2 caps created right there in the blue area, when we take this over to CFD, it recognizes that watertight area and creates a surface force. And so it actually creates that volume that's listed right here in the Design Study Bar browser that I didn't have to create. So it filled that void. So we're going to do some pressure testing here of water coming through this, and CFD created that surface for us, showing where that open area was inside that valve. So without having to do sculpting and surfacing tools inside of Inventor or your CAD package to create that void, by having those caps on there, CFD automatically created that void for us. So once we've got this in here, we've got some unassigned components, and we've got some aluminum components. So I'm just going to drag a window around everything, and we can edit those via the ribbon menu or via right-click and edit. You're not locked to one way doing that, and I'm just going to change everything to aluminum at one time. And so now everything goes to aluminum, and then that volume that CFD created for us, as well as those two caps that represent the water, I'm going to edit those and tell the software that those are fluids and those are water. And so just very quickly, just change that to fluid, change that to water, and now I've got a legend here with the water in blue, the aluminum in the gray area, showing what is there. Once I've got material set up, then I'm on to the boundary conditions. So I'm just kind of following that left to right workflow here. So I go to boundary conditions, and in this case, we want to test what happens when we push water through the 6 variations of our model. So we're going to start at the inlet, select the surface here, and edit and apply a boundary condition. So all right, we're going to check our flow rate, and we'll go gallons per minute and say, all right, we're going to put 50 gallons coming through here. And if it's coming in, it's got to go out. So we'll select this other face here and say, all right, this is where we're going to come out with it, and we'll just apply a 0 pressure at this edge. So now I've got a legend that's showing my flow rate and my pressure. And that color bar on the legend matches the color faces here. So I've got a kind of a cyan line here and a more mustard color line there, and that represents the legends from the bar here. So after I've got my material set up, my boundary conditions set up, I can now mesh the model, and that's where this auto size comes in, doing the auto meshing for me. And so I don't have to select individual faces or inside of the bolt hole patterns and say omit this or anything. Just let the software do that for me. And now once I've got all that done, I'm ready to solve. Now when I start to run the analysis here, I can do this locally or to the cloud. I'm going to do it locally. I'm going to run 50 iterations here and select solve, and then very quickly the software will take off and it'll start generating the mesh and creating the mesh. And one of the nice things about this is as soon as this starts running the results, we can start looking at them. And so it's going to go through and start at step 1 and go up through step 50, but as it's running, we can go ahead and start looking at the results. So on the results tab, I can go to my planes here and add a cut section if I would like. And I can see the jet coming out here where all the pressure is. So I can change my vectors here to looking at the velocity. And then I can see as it's going, it's almost through with those 50 iterations. Now it's complete. And so very quickly it runs those iterations for me. And so you can set it up to run as many of those as you would like. In this case, we just went with 50 for time's sake. And so now I can come in and edit these vector settings, and if we want to see those arrows a little larger, we can just adjust the slider bar here, see more of those, less of those, what we're looking for, and we can kind of see where that's going. We can even change this to an outline here to give us a more clarity. We kind of see, all right, so as we're pushing the water through, here's where it's going, and if I zoom in a little bit, we can see there is my large opening that was in my design variation 1 inside of Inventor. So I can look at the planes there, I can go over and I can plot points if I want to plot some points, add some points here. Let's zoom out a little bit and we'll just add one here. We'll just add a few points kind of in the middle of where our flow is going, and say plot those, and then we get a graph here showing us where they are. I'll kind of drag that out of the way. Now if we're going to compare these, if we want to look at different variations, in this case we do, inside the plot box here I've got this summary checkbox that will save that view so that I can look at it and compare it side by side to another variation. And so I can close that, and I can turn the plots back on and off if I want. Everything is kept over here in the design bar, in the design study bar, and so I can turn that plane on or off at any time. Remove it if I no longer need it, but I can just hide the visibility if I don't want to see it. I can go over to my traces if we want to see the traces, the particle traces. Come over and make this circular, and we'll add some there, and then we can see our traces of where the fluid is going when we're pushing it through. And so again, we can kind of see the jet as it's coming out the valve here. The high pressure points, the low pressure points, kind of got a graph here as to where we're at, where we're going. We can create ISO surfaces if we want to create one of those. To show that, ISO meaning singular surface there, and we can change this to our pressure if we'd like to see our pressure, and we can change that. We can go to the settings here and look at our results, and again we can change the bar here a little bit, slide this back, control the arrow size so that we can tell the story of where our pressure is coming and where it's going. So once we've satisfied with that, we want to check another variation. We can just easily come up here to Design Study 1, right click on it and select Clone, and that will allow us to create another one here inside of CFD. So without having to leave, set up another model, we can just clone this one here, and I'm going to select the defaults of Design Study 1 or Design 1, copy 1 there. So now it's going to duplicate what was already there. So I'm going to go back to the inventor side, and I'm going to make choke valve 02 active right here, and so that makes my variation here active. And then I'm going to select Launch Active Model again, but instead of creating a new model, when the dialog box pops up here, I'm just going to select my Update Design and go select the one I just created, which was Design 1, Copy 1, and say Update this design, and then nothing else required. Come back over here to CFD, and let's hide the body. Let's hide the surface that it created, and there is my variation 02. So I can just clone it, update the design on the CAD side, update it back to CFD, and it beats me back over here. My materials are here, my boundary conditions are here, my mesh is already here. It's ready to run the analysis for this design variation, and then I can start comparing results. So easily I could clone that 4 more times since I had 6 iterations there. I do have a model up with all 6 already loaded, and so we've got the setup, we've got a results tab, we've got a decision center here, and we'll go to the view, and we will change our viewports to our side-by-side comparison. And then we're looking at 4 models right now, and as you zoom into one, and once you're through zooming, the others will update as well. So I'm using a 3D mouse. If you have one, if not, you can just use your cursor to zoom in, zoom out. So now they're all Design 1, Scenario 1 currently. So I'm going to select in this area here for Design 1, Scenario 1, and we'll change that to Scenario or Design 2. And we'll change this one to Design 3, and we'll change this one to Design 5, and we'll go to 6 on this one. And so we can compare the results from any of those studies we ran from those different variations at one time. And so if I come back to zoom in on this one here, where I can look around at what's happening here coming out, all the others automatically update. So if I say, you know what, on Design 5, instead of the pressure ISO, maybe I want to look at the pressure drop. And so I can just drag and drop the pressure in there, or maybe it's the velocity I want to look at, and just drag and drop it into the window. And then as I start zooming in, the others update and zoom into the same orientation and zoom ratio as well. And so I can just compare the results, and I can see, all right, well, Design 5 looks like this, Design 3 looks like this, Design 2, and Design 6. And so just very easy to go back and forth and compare those results and see, all right, so we put 50 gallons a minute coming in on the inlet, negative pressure coming on the outside, and what happens here. So we've got our different results, our different variations from our model that we can run, and just makes it very easy to work through. We've got the view cube here inside each viewport that we can utilize. We've got the navigation bar inside each viewport here that we can utilize. We can hide the output bar for larger visualization once we've determined this is what we want to look at. And again, as we rotate one and release, the others update as well, so that we can look at all 4 results. In this case, we've got the 4 shown there at one time. All right, so that's kind of a very easy, quick and simple demonstration of the CFD as far as fluid flow goes running there. So I will flip back over here to my slide deck. And so the software side, CFD and FEA comes in a wide range of applications. Very quick what-if studies like we did right there, assigning materials, setting the boundary conditions, meshing, running the results, looking at the planes, looking at the traces, looking at the isosurfacing, being able to validate those designs before creating costly physical prototypes. We, as Hagerman, we do offer customized training using your own models. We have some testing models we can use. We also use the live models working directly with customers. Web-based interactive e-training, ongoing mentoring for continued education and results. We also have a SIM services specialist group that provides CFD and FEA testing. Quick turnaround with that. That we can help you with if CFD is out of your realm, but you needed to run some analysis on some models. We have a dedicated team that can help you with that. So with that, we will flip it over to the question area if there are any questions. If there are not, this will conclude our webinar. Very short today. Didn't want to take up too much of your time, but we do thank you for attending. But if you do have any questions, enter those in now, and we'll take a look at those and see if we can provide any information for you.
Mark, I don't see any questions popping up, but I want to let people know that if you think of additional questions, you can simply reply to the confirmation or reminder email you receive from GoToWebinar, and we can get those to Mark to get your questions answered. Once again, if you could take a few moments to fill out the survey, we would appreciate it. It will just automatically pop up as we close down the session. And if there's nothing further, we'll just thank you for attending and have a great day, everybody.